Hey, today we are going to explore how enterprise AI agents connect to the backend systems. This is done using the architecture that you're seeing here. You could either use Microsoft Copilot Studio agent and our Azure AI Foundry agent and our any other third-party agents that come out of the box, or the data agents that are available as part of Fabric, Databricks, etc. So, as part of secure, governed, and repeatable patterns, Agent Factory is the place where you manufacture the agent. I mean, create the agent, register the agent, and provide a unified way for your enterprise um, to actually um, follow the best practices while creating those agents. Um, then, once the agents are created, you could orchestrate these agents using orchestrator of your choice, semantic kernel, lang graph. In this case, I'm using semantic kernel. The agents connect to tools, large language models, and custom connectors. Uh, so today we are actually talking about Copilot Studio that uses a custom connector to connect to the MCP server that have access to your enterprise data, and thus you will provide the context to the large language model to respond more intelligently to your Copilot Studio um, agent. Also note every request is passing through API Management Gateway. MCP stands for Model Context Protocol. It is a standardized way of for AI agents to talk to enterprise backends. Instead of writing custom integrations, MCP servers provide a structured layer to expose business logic, rules, and our data. In simple terms, MCP makes enterprise systems speak AI. So, how do API management and MCP work together? In API management, we configure inbound policies to check tokens, rate limits, backend connections to MCP servers, and outbound policies to normalize responses. This means developers don't need to worry about security or networking details. They just call API management. API management handles secure connectivity to MCP servers. And because all traffic goes through API management, we get full tracing and monitoring with Azure Monitor and App Insights. So in today's demo, I will show you how the Copilot agent uses the custom connector to connect to the backend MCP server that is created on a PostgreSQL database. Let's go into and jump into our demo. I have my local MCP server running on port 8000. So let me show you some of the sample MCP calls that the connectors need to make. So every MCP connection starts with initialize, and once it get initialized, if you see here, the next step is you can ask for what are the different tools available. Of course, this is a database MCP server that is actually exposed through API Management Gateway. You can see several different tools such as get databases, get table stats, or execute a SQL query, which are some of the common things we need. So, as an example, if I uh, make a call on the get databases, um, you can actually see, this is the payload that we get back, right? So um, the backend MCP server is saying that it has access to a finance database and all these different kinds. So let's see how we can configure the MCP connector from the Copilot Studio. So log into your Copilot Studio. So once you log into the Copilot Studio, um, go to agents. So of course you can create a new agent. I created a fashion agent, right? So after you create the agent, um, you need actually to add our MCP tools to the agent. So how could we actually create this particular tool, right? So for example, let's say add tool, right? So once you add a tool, that is your model context protocol. And there are some MCP servers out of the box, but if you create any custom MCP servers, they will appear like that, right? So right now I already created, but when you are doing it very first time, new tool, the custom connector right there, you choose that custom connector. That will take you to your Power Apps custom connectors. So in Power Apps, if you actually say new custom connector, and you can actually import an open API file, and that open API file, yeah, this is an example of MCP schema you need to provide for the tool. So all this says is you are using HTTP streamable protocol for the MCP server, and you will be invoking MCP. This is like a boilerplate code. You will do invoke MCP operation, and then our MCP server is backed by API management gateway, and I expose the MCP server at the base path, whatever that is, and that's it. This is just a one-time thing that you need to provide, and after which, once you come back, for example, if you want to see one of the things that I already did, so this is a Swagger editor. If you do that, see, I copy pasted the exact same thing, and you update that connector. That's the custom connector piece. So if you actually see our architecture diagram, so this custom connector is that custom connector that I have created. We did all this for configuring that, right? So to your agent, let me cancel all of that out, and that connector will appear as a tool. And once you have the tool, just if you click that tool, right, and establish the connectivity to the backend, look, it recognizes the same exact tools that we have seen before. And if you interact with your agent here, for example, let me ask, provide me the list of tables in fashion database. And during runtime, what happens is it is going to use this particular tool, because it knows it has to go fetch that. And sure enough, these are the different tables available in the fashion database. You can also ask, show me some sample records from uh, from visits table in fashion database, and you go there, and sure enough, it should provide us, you see, it is providing us some of the sample records. So this is the context that your agent uses, and you answer, right? For example, put it in the context, when would we use that? For example, you can say, what is the most latest visit for user Shri, chatting over there on the right hand side. What is happening is, um, it will be invoking a GPT-4o model. The GPT-4o model doesn't know how to respond to that, right? In the absence of the MCP server. So in this case, when we said what is the most latest visit for user, um, you know, it had to respond, explore rich history and European culture, and all the other things, right? So it gets that context through the tool that we have provided, and it uses the custom connector um, to reach. And also, one more thing to note, in our Copilot Studio is, if you actually go to your settings, advanced, you can actually create application insights, connection string, and you can configure to log all the activity to the application insights. So this is what we were talking, right, for the distributed tracing. So all the agents in the Copilot Studio could talk with your application insights, so that you get deep telemetry at the Copilot Studio layer. So that is something to keep in mind. And after that, all you need to do is you need to publish your agent. Once you publish your agent, then your agent is discoverable um, from any of the orchestrator. And I will show you how is everything. So kernel function pretty much um, wraps the functionality of this interactivity that you are seeing here. It is not important to go through this code itself, but I'm showing this so that you get an idea of how, after the fact that you have created a Copilot Studio agent, your enterprise IT could actually bring it into the semantic kernel orchestration ecosystem, so that it could be productionalized properly if it could be used for other domains. So you could ask the same question again, and like you get the same responses here. So I will actually put the GitHub link underneath, and you can copy paste the code from there. um, this is not really important, but the important part is the architecture, right? So we are using semantic kernel to invoke the Copilot Studio that actually uses a Power Apps custom connector to reach out to an MCP server backed by API Management Gateway. And the MCP server which we used is a PostgreSQL database. And also we perform distributed tracing, um, and we can see those insights. And I will now show you how the tracing appears in the application insights, and that completes the end-to-end life cycle in this video. Also, you need certain things from your Copilot Studio. Don't forget. So if you go to the settings, and go to advanced, there is this section called metadata. In the metadata section, you need to copy your environment ID and the agent ID that is shown here in your env file, so that your IT department knows which agent to call and which environment um, that agent exists. This is true for anything, not necessarily the MCP Copilot Studio agents. As you can see here, our call to the Copilot Studio agent is logged as a custom event in the application insights, and it is of type bot message send, and you can see the response we got from from the LLM that reached out to MCP server. So this is an example of end-to-end distributed tracing. So to put it all together, we start with Copilot Studio agent. We use custom connector. We use an MCP server that is backed by API Management Gateway, and it reaches a database, and then it responds back to our Copilot Studio.